Taming the inferno. Just imagine the immense energy that slumbers in a single fuel tank. Thousands of liters of highly explosive liquid, where just a tiny spark can trigger an absolute catastrophe. We are looking today at how a clever technology interrupts exactly this chain reaction before it even really gets going. For the emergency responders who have to go in there, this is a harsh reality. In the world of fuel storage, where the risks are simply gigantic, they fight against time and against a force that seems almost uncontrollable. They react to an inferno that is already in full swing. But what if you could simply interrupt exactly this chain reaction? What if there was a way to take the event's most dangerous weapon, namely the explosive shockwave and a subsequent wall of fire itself? What is eXess? And exactly here comes a technology into play that promises exactly that. But forget everything, what you know about conventional extinguishing systems. This right here is something else. A true paradigm shift, away from pure reaction, towards proactive suppression. This right here is eXess. No chemical, no gas, but a physical metallic 3D structure. And it was not developed to prevent the ignition, but to neutralize its catastrophic consequences. And this is how the whole thing looks. A very light metallic mesh. But in this open pore structure, there lies the ability to virtually absorb the massive energy of an explosion and transform it into an event that you can control. What is really fascinating here is the efficiency. Look, eXess fills up a mere tiny 1.5% of the tank volume. The loss of storage capacity is thus practically zero. And with just 45 grams per liter, it is light as a feather and displaces hardly any valuable fuel. Taming the shockwave. Okay, but how exactly does this physics work in this one critical moment, when the spark jumps? And this right here is the crucial point that you must understand. eXess accepts the spark, but it takes away its resulting destructive force. So it is not about preventing the cause, but to control the devastating effect and thus to avert the disaster. All right, let us go through the process. Ignition occurs. The ignition temperature is reached. Normally, this would generate with an explosive gas-air mixture a massive shockwave, which rises so fast that it simply makes the tank wall burst. But exactly here, eXess steps in. The 3D structure acts like a giant shock absorber as an energy absorber for the explosion. It absorbs the energy, the pressure rise rate is drastically slowed down, and the peak pressure is reduced to a manageable level, the P-red reduced. With gasoline or propane, these are then, for example, only 300 millibars. Thus, a potential disaster becomes a controlled deflagration, and any subsequent fire is controlled. The burn rate is halved, and the fuel is consequently much less contaminated and polluted. This core principle is designed for intelligent applications and highly versatile. The installation takes place in floating roof tanks on the roof. For fixed roof tanks, eXess is placed onto the internal floating roof lying in front of it and secured. Let us look at three main applications. These are initially internal floating roof tank. These are massive storage tanks with an internal floating roof. Between this floating roof and the fixed roof above it, a highly explosive vapor-air mixture collects. Lightning strikes and electrostatic discharge are a frequent ignition source here. eXess is installed in this hazardous space to suppress an explosion from the very beginning and to keep any emerging fire under control. The benefits are enormous. Besides the safety protection, it also reduces the escape of harmful gases, volatile organic compounds. Rim seal application. The second application targets the rim seal. Here, flammable vapors constantly escape. One spark is enough, and the edge is in flames. eXess is placed precisely fitted in this area. Full surface protection on the floating roof. Here we use the developed safety floating roof rolls called SFRR. These floating rolls cover the entire surface of the fuel. The innovation is that these are designed to float. In the event that the floating roof goes down, the floating roof rolls float on the fuel surface. They act like a metallic wick, absorb the energy of the shockwave, and keep a potential fire small and controllable. Safe rescue time. The mode of action of innovative eXess material is, besides the safety increase as explosion suppression, also that the heat radiation is reduced by a massive 90%. The burn rate drops by more than half. The fire is significantly smaller, cooler, and less intensive, and thus controlled. Smoke generation is reduced by about 90%. Emergency responders can get closer to the source of the fire and perform the firefighting more targeted. Consequential damages are lower for personnel and plant operators lower. Risk reduction for personnel, the loss of a potentially entire facility. This leads to the one priceless asset, namely time during firefighting. That means more time for emergency responders to safely act, evacuate, and extinguish the fire. eXess works not against, but with the existing systems. The result is minimal damage, maximum safety. eXess, SFRR, complies with the regulations for the construction and operation of floating roof tank facilities according to specified standards such as API 650 and complements or exceeds these in a positive sense. American Petroleum Institute API 650, 653, 620, and 2000 European Committee for Standardization CNEN 14015, Explosion Protection, ATEX, 2034, EU, in combination with National Fire Protection Association NFPA 11 and NFPA 30. During the installation of eXess, the specified safety standards and national regulations must be followed. Generally, it can be said, there are no special operational interruptions during the installation necessary. A retrofitting is recommended with a full tank when the floating roof is in the highest position. For a fixed roof tank first, the internal floating roof IFR has to be installed and afterwards eXess is installed on the roof. In this case, eXess acts as a pressure absorber and reduces the energy in the event of a shock wave and thus a possible bursting of the fuel tank. The maintenance effort is low, and the training for the security personnel is just as low. Requirements are given by the manufacturer of the company, Fuca's company. After the installation, a training is conducted. This is given with a small time expenditure of a maximum of half a day. By the manufacturer, a periodic at least one-time yearly visual inspection is recommended. To be checked is only the coverage of the floating roof surface and whether the eXess SFRR is in good condition. The investment costs for the safety increase are calculated as one-time investment costs on the tank content to be stored. Thereby it is assumed that the tank is filled 7 times per year, has a lifespan of 7 years, and the average fuel price is 1.5 euros per liter. These are shown for the individual applications in euros. For the application internal roof IFR, only 30 euro cents per 1 cubic meter of fuel. These are compensated by the high emission reduction in a few years. Converted, it costs the fuel customer less than 1 euro per year, with driven 30,000 kilometers. For the application floating roof in the rim seal area, it looks as follows. The investment costs amount here to only 7 euro cents per 1 cubic meter of fuel consumption. Converted, it costs the fuel customer only 14 euro cents per year, with again calculated 30,000 driving kilometers. For the safety floating roof application SSRR, the investment costs for the operator are in euros per 1 cubic meter of fuel 60 euro cents. Converted, it costs the fuel customer slightly over 1 euro with a calculated 30,000 annual mileage. Who are now the winners? The end customer participates in the safety increase and environmental protection. The state through creation of workers and tax revenues. Insurances through damage minimization. Actually, everyone. The perfect tank facility. A large fuel storage is so designed that fires are quickly detected by automatic extinguishing systems and safety mechanisms and controlled, whereby damages normally remain locally limited. However, if a part of the system fails caused by a force majeure like an earthquake or a terrorist attack, an explosive resulting fire can rapidly and uncontrollably spread in a short time, engulf other tanks and cause an escalation with severe structural damages and large-scale danger. For example, a scenario. After 8 minutes, a fuel storage tank standing in full fire is out of control and lost. The industry standard deployment time of a trained company fire brigade is up to 15 minutes or more. The state of the current extinguishing technology is to save fuel from the burning storage tank and to protect the neighboring tanks to limit a domino effect. The goal is the protection of the neighboring tanks with simultaneous product removal from the burning tank, whereby the cooling internal effect is lost and the tank shell is thermally weakened or damaged. Thereby, burning fuel can escape, spread in the containment area, and cause an escalation with a domino effect, which endangers the entire tank farm. An innovation with the floating roof tank SFRR consists in that in the event of a fire, the cooling fuel located in the tank shell does not have to be pumped off. Instead, the cooling effect of the existing product is specifically used, while the fire is directly extinguished. The core idea of the innovation is that through the existing fuel product quantity not as a risk, but as an active component of passive fire protection, whereby time, effort, and consequential damages are significantly reduced. Extinguished by the company fire brigade with the advantage of gaining time. The core statement is that the purely mechanical eXess protection represents an independent and fail-safe security level. At the same time, it makes a contribution to active firefighting, since it functions automatically in the event of an incident through its presence and thus unfolds its protective effects, even if other protective measures like electrical, digital, or organizational systems fail. The mechanical eXess protection increases the overall safety, because it remains permanently effective as an independent, self-sufficient, and fault-tolerant protection layer. After the installation and training, there is an installation document. This also serves at the same time as insurance cover for a failure of the eXess material. Existing patents were expanded, and a new patent under PCTEP 2022-069971 filed to have the positive properties of eXess not only in the fuel tank, but also available in the catch basin. Through the retrofitting of the eXess safety product, the storage tank is elevated to the state-of-the-art. Economic efficiency to the benefit for all.